In this video, we're going to look at, instead of the name to the formula, we're going to go from the formula to the name. But I still want us to write down the ions. So for instance, Na3N, Na from column 1A will be an Na with a 1 plus. Now notice we already know that there's going to be 3 NAs, so I can write Na plus, and Na plus, all 1 pluses. There's 3 NAs, but each Na from column 1A with 1 valence electron, losing that 1 valence electron becomes a 1 plus. Then N, there's only one N, and N on the periodic table is column 5A, and that's a 3 minus. So now the name of that, and you'll see that the charges match. 3 Na pluses for 1 N3 minus. Plus, 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 cancel out with a 3 minus. These will always cancel out. So the name becomes sodium. The metal's name does not change, but the non-metal's name changes. So instead of nitrogen, we will call it nitride. We change the ending of the non-metal's name to IDE at the end. When we look up Mg, Mg is in column 2A with 2 valence electrons, so it's an Mg with a 2 plus. There is only one of them. Whenever there's one, we don't write the one. It's an invisible one. And then S is a 2 minus. Column 6A with 2 valence electrons, so a 2 minus, and there is only one, an invisible 1 on the S. This makes sense because the Mg with a 2 plus, one of them, cancels out with an S with a 2 minus, so it's a 1-to-1 ratio, MgS. The name becomes magnesium sulfide, IDE. It was sulfur, and we changed the ending to IDE. For the last example, we're going to look at barium. Barium is in column 2A with 2 valence electrons. It's a Ba with a 2 plus. We can see from the formula there is only one of them. I in column 7A is a 1 minus. It already has 7 valence electrons, so it wants to gain one more, an I minus. The formula tells me there are 2 I's, so it's Ba with a 2 plus and I with a 1 minus, and there are 2 of them. Notice the charges on ionic compounds always cancel out, so this becomes barium, and instead of iodine, we change the ending of his name to IDE, and it becomes barium iodide. Something that I want to point out is a lot of teachers, right at the beginning of the school year, will have you up above this column put a 1 plus, up above this column put a 2 plus, because all of the 1A column becomes a 1 plus, all the 2A column becomes a 2 plus, all of the 3A becomes a 3 plus. 7A with 7 valence electrons becomes a 1 minus. 6A becomes a 2 minus because it already has 6, so it wants to gain 2 more. 5A becomes a 3 minus because it already has 5 and it wants to gain 3 negative electrons. Column 8A does not have a charge because it already has 8 valence electrons, or in helium's case it has 2, but in energy level number 1 you only can hold 2 electrons, so it's full. And we haven't learned about column 4A. It's right in the middle, so we're going to find out in the next unit. These ones like to share electrons. And we've talked about this D sublevel being very interesting, and it can do multiple different types of charges. And typically, we use our oxidation state chart to figure out what kind of charges they have. So on the oxidation state chart, we would look it up, and there's some multiple options, and we'll be talking about how we deal with those in the next coming lectures. So The reason we don't do this right at the beginning is I don't want you to get caught into just memorizing information. I want you to understand why column 1A is a 1 plus, why column 2A is a 2 plus, why column 7A is a 1 minus, and column 6A is a 2 minus. It's based off the structure of the atom and the valence electrons and the principal quantum numbers and the quantum mechanics of the atom. I hope this helps understand how to go from the formulas to the names of the binary ionic compounds.